Hello learners. Today we'll see the relation between phase difference and path difference. So you can see the wave that is represented here. So we have discussed earlier the basic terms or the definitions of the waves, right? So this is the amplitude. So here, okay, lambda. What is lambda? Lambda is the wavelength, and this is a positive cycle side and this is a negative cycle side. Okay, and we have drawn 2 points P1 and P2 on the wave. Okay, this is a half the displacement, half displacement, that is represented as x, and till P1 we have represented it as x1, and till P2 we have represented it as x2. Okay, and this is lambda, the wavelength. Okay, so here this is the way how the wave is represented. Okay, so the equation of the wave can be represented in this form: y of x comma t is equal to a sine omega. Wait, I'll write here, 1 second. So the wave, the equation for the wave is represented as, 1 second, y of x comma t is equal to a sine omega t minus x by v, or can also be represented as y of x comma t is equal to a sine kx minus omega t. Okay, so this equation 2 represents the displacement of a particle at a distance x from some fixed point at some time t. Okay, in which direction? In the direction same as that of the direction of propagation of the wave. So therefore this is the equation of the wave. And what type of wave is this? This is a transverse wave. Okay, so light is a transverse wave, so we can say this as a light wave also. Now let us see the relation between phase difference and path difference. Okay, phase difference and path difference. So to relate the phase difference, okay, to relate phase difference and path difference, we should concentrate on two particles, that is P1 and P2, that we have drawn just now on the wave. Okay, P1 and P2, which are at a distance x1 and x2 from the origin. You can see this is a P1, this is a P1 which is at a distance of x1, and this is P2 which is at a distance of x2. Okay, x1 and x2. So we can write the relation between phase difference and path difference. Okay, phase difference and path difference. So how? Phase difference between these 2 points P1 and P2 is equal to 2 pi by lambda x2 minus x1. Okay, phase difference between P1 and P2 is equal to 2 pi by lambda x2 minus x1. So therefore phase difference becomes 2 pi by lambda. What is this x2 minus x1? x2 minus x1 is nothing but path difference. Path difference denoted here. Okay, so when two or more waves overlap in some region of space, intersecting effects are observed. Okay, so how can you remember the expression for the phase difference? Phase difference is equal to 2 pi by lambda path difference. That can be obtained like remembering that the difference in the phase of 2 pi corresponds to the path difference of one of the wavelength. Okay, so you have to remember this expression, it's very important. Okay, phase difference is equal to 2 pi by lambda path difference. Next, do you remember the superposition of two waves, right? Let us consider an example. When we drop two stones simultaneously in a very quiet pool or some drum or something like that, so we will notice that there are set of waves that are created in the water. Okay, so what can you observe? You will note that there are some places where the disturbances is not there at all, right? The disturbance is almost zero, and at some places the disturbance is greater than either of the wave. Okay, so these effects can be understood like in the terms of principle of superpositions, where the two waves they are traveling simultaneously, and the resultant displacement of each particle of the medium is the vector sum of algebraic sum of the displacement due to each wave separately. Now we'll see the superposition of two waves of same frequencies but having constant phase difference. Okay, so now let us see, does superposition of two or more waves influence the amplitude, frequency or other characteristic? Okay, the superposition of wave influences the amplitude, frequency or any other characteristics. So let's see. Okay, now we shall consider two sinusoidal waves. They are traveling in z direction. Okay, so the solution of these two the solution of the two waves, I mean the solution of equations represents the displacement. So let us write the solutions. That is x1t is equal to a1 cos omega t plus pi theta 1. Let this be equation number 1. And x2t is equal to a2 cos omega t plus theta 2. Let this be equation number 2. So we assume the displacement of these two waves are in same direction. Okay, but they are having different amplitudes. Okay, and different phases. Phase differences not constant or zero. Okay, phase difference is varying, amplitude is varying, but they are moving in the same direction. Okay, so according to superposition principle, we know, according to superposition principle, what do we know? The resultant amplitude, the resultant displacement, the resultant displacement x of t is equal to x1t plus x2t. If there are more waves, then we can write more. Okay, that is a1 cos omega t plus theta 1 plus a2 cos omega t plus theta 2. Okay, next, so on simplification by some trigonometrical values, we get, I'm writing the final result, x of t is equal to a cos omega t plus theta, equation number 3. Further we have to square this. Okay, squaring it and adding it, we get resultant amplitude as a is equal to a1 square plus a2 square plus 2a1 a2 cos theta 1 minus theta 2 under root. Okay, let this be equation number 4. So in the fourth equation, if we assume theta 1 and theta 2 are similar, they are equal to 0 or 2 pi or 4 pi or 6 pi, so on up to 2 pi n, where n is equal to 0, 1, 2. Okay, where n is equal to 0, 1, 2 and so on. Then what happens? Then a is equal to a1 plus a2. A is equal to a1 plus a2. Thus, if two displacements are in phase, yes or no? If they are in phase, then the resultant amplitude is, how is the resultant amplitude? Resultant amplitude is the sum of the two waves amplitudes. So this is known as constructive interference. Okay, this is known as constructive interference. Okay, the resultant amplitude will be the sum of the two amplitudes, and this is known as constructive interference. Hence, for constructive interference, we can say a few points. We can say that amplitude is maximum. We can say that phase difference is, how is the phase difference? Phase difference is integral multiple of 2 pi. Integral multiple of 2 pi. Okay. Or we can say path difference. Path difference is integral multiple of lambda wavelength. Okay. That means if here a1 is equal to a2, then what this how this equation becomes? This equation becomes like a square is equal to 4a1 square or 4a2 square. That means what is happening? We know a square is equal to intensity, right? The square of the amplitude is intensity. So intensity is becoming 4 times more. Okay. Intensity becomes 4 times more. You can write that point here. Intensity becomes 4 times. Okay. I hope you understood. Now similarly, if theta 1 and theta 2 are pi, 3 pi, 5 pi, 7 pi, odd numbers, okay, so on up to 2n plus 1 pi, where n is equal to 0, 1, 2, 3, so on, then what happens? Then a will become a1 minus a2. That means the resultant amplitude. How is the resultant amplitude? Resultant amplitude is the difference of the two amplitudes. Difference of the two amplitudes. Resultant amplitude is equal to difference of two amplitude. So, which interference is this? Yes, this is known as destructive interference. Destructive interference, and we can write few points about this. We can write that for destructive interference, amplitude is minimum, right? And what about the phase difference? The phase difference is an odd multiple of pi. Odd multiple of pi. Okay. And what about the path difference? Or we can say the path difference is an odd multiple of half wavelength. Half wavelength, that is lambda by 2. Okay. So if at all a1 is equal to a2, then what happens to the resultant amplitude? a1 minus a2, no? So a is equal to 0. Means here intensity. What about the intensity? Intensity is 0 or very minimum. Intensity is 0. Okay. And we have just seen that path difference of wavelength lambda is equal to 2 pi phase difference. Path difference is equal to 2 pi phase difference, that is lambda is equal to 2 pi. So hence what we can write, once again, 2 pi phase difference. So hence path difference for constructive interference or constructive superposition. Okay. Path difference for constructive superposition or constructive interference is equal to, that is delta is equal to lambda by 2 pi into 2n pi. Okay, 2 pi cancels, n lambda remains. So path difference for constructive interference delta is equal to n lambda. Similarly for destructive interference, okay, for destructive interference or superposition, the path difference delta is equal to lambda by 2 pi 2n plus 1 pi, right? So that becomes delta is equal to 2n plus 1, pi gets cancelled, lambda by 2. Delta is equal to 2n plus 1 lambda by 2. This is for destructive interference. Okay, and the constructive interference, it is n lambda. Path difference for constructive and destructive interference we have derived. So I hope you understood about this, right? Okay, thank you.